Hey folks, today we have a different kind of video. We have something on the repair bench. This is an Apple IIe power supply, which appears, judging by the date code, 8550, to be from the 50th week of 1985, assuming that I'm reading that date code correctly. Not user serviceable. Yeah, we'll see about that. There's the old Apple logo there. It's an Aztec power supply. 115 volts AC, 50 to 60 hertz. Has a hard on-off switch. Here's your outputs. It even gives you the pinout on the back too, which is really nice. 2.5 amp. You get 5 volt, 12 volt. You get plus 5, plus 12, minus 12, and minus 5. It's a very simple power supply. And then there's common grounds here. And the pinout for the connector there, which is great because that'll allow me to test it with my multimeter to make sure this thing's working. Power supply was made in Malaysia, so made in Malaysia, but an American will be servicing it. So let's take a look at the inside. This power supply does have a problem. The last person who owned this, who turned it on, had a capacitor go boom, from what they heard, and I opened it up and absolutely confirmed that. And you take a look at these electrolytics, and they look fine for the most part. You know, they just look like your typical electrolytic caps. Even these here look fine. These here maybe gotten a little big, but there's a cap down in there. I'll use my soldering iron to point at it. There's a cap right down in there, which burst and leaked stuff all over the motherboard last time it was turned on, which was, I'm not really sure how long ago that was. Maybe it was within a couple years, I think. And a little bit hard to see, but you can kind of see there's a bunch of goop and crap all over the motherboard. Look at down there. Ew. The thing literally burst. So that's the main cap that's a problem. The rest of these being replaced are simply because the power supply is about 30 years old. And at that point, you really want to start replacing stuff. But while we're in here, we'll take a look at the structure of this power supply. Obviously, you start with the AC input, which doesn't appear to have any filtering directly on the plug. And then those leads go down in what looks like 3 different places. Yeah, you have it. I think it goes from there into the switch and to the chassis for ground, right there. Yeah, you have your brown wire going into the switch, and then another brown wire coming out of the switch to the board here. Where's the green wire go? The green wire goes to ground. The blue wire goes directly into the board as well. So you start there at the AC filtering lines. So you have that bolt. You have that busted capacitor there. Underneath this you have, looks like a transformer, some film capacitors, which are the yellow ones there. There's a fuse. There's some more down there. And you have some filter caps here. You have what this, to me, this I think is a voltage regulator. It looks like a transistor that's being used as a voltage regulator. Some more caps. Another cap there. Transformer here. Tiny transformer there, if that's indeed what that is. And then here's your output here, with a bunch of filtering on the back of it through these capacitors here. And there's various lines of resistors and stuff throughout the board. It's a pretty simple power supply. On this channel, we've taken a look inside some other power supplies, and you can see the old ones were pretty simple. And they don't really put out much power either. Newer computers use a lot more power than the old ones did. The old ones didn't have fans and very power-hungry graphics cards. So they really didn't take up or need much power. I think the thing that took up the most power was probably the CRT. Anyway, so what we need to try to do is try to get the board out of this thing. And what I have here are some capacitors from Mauser in this box. So we'll take a look at those. Alright, here we have some capacitors. As you can see, the new ones are much smaller than the older ones, simply because 30 years have gone by and you can pack a lot more capacitor into a little can like that. These are the, what are these? 330 microfarads, and they're tiny. There's some more. These are 47 microfarad, 250 volt. Now, where would those be on the board? I think, yeah, that's filter caps here. Look how big these are. These are from the mid-80s. And then you compare that to these. It's kind of the same width, actually, except it's just shorter. So you could so they could compress a lot more of a cap into there. And by the way, the capacitor I'm using for the majority of this project are Nichicon PW series capacitors. These are power supply. These are rated for. Is it very high impedance or very low impedance? I cannot remember. I'm blanking on it. Crap. Either way, they're designed for power supplies. The PW series generally is. It's what I use to repair a lot of the monitors I've done in the past, so we're going to use those. And for that film capacitor down there that exploded, we're going to use one of these. At least I hope this works. This capacitor is a 0.1 microfarad 250 volt cap, which is exactly what that is. Exactly what that was. So hopefully this little guy won't explode on us either. If it does, I'll get a surprise, and I'll have to order a new capacitor. So, yeah, hopefully this one doesn't go bam. All it does is filter the AC line, which is why this cap dying really didn't kill anything else, as far as I can tell. It was just that. The power supply actually worked when he used it, but that cap had just gone explode. So, what I got to do is get the board out of here, fire up the desoldering iron, which really looks like it's seen better days. I need to get myself a real soldering station someday instead of using this crappy Radio Shack stuff. And yeah, let's get this stuff started. Wow, that board was a pain to get out of here. I struggled like hell with this stupid strain relief. These things are so annoying to deal with. But anyhow, I got the board out. I had to unplug these connectors from the power switch there. If those are a bit flaky, I might just solder them on. But here's the bottom of the board. The solder job looks fantastic. Look at that. It looks wonderful. Those people in Malaysia did a wonderful job with this board in the 80s. Really nice soldering done there. My soldering doesn't look quite as nice sometimes, so by the time I'm done with this, yeah, there you go. We'll get a closer look at the board now. Looks like there's some glue under there. I don't know if I'm going to clean that or not. I think that's actually, I thought that was capacitor goop, but I think that's actually glue that's meant to hold this oak tag or whatever this stuff is down. It says oak on it. I'm going to guess it's oak tag of some sort. Feels like plastic, though. Anyhow, we can get a better look at that capacitor that went kablooey. Move this out of the way. Look at that. That capacitor really, really went kablooey. You can see it's a bit open there. And there's some crap all over the board. I'm going to clean that up with some alcohol. See, look at this and make sure I actually got the right capacitor. It says 200 volt, 250 volt, tilde MP, and then up top it's 1 comma or 0.1 microfarad, but 0.1 I think is just fine. It's a This is the cap that's replacing it. Look how much smaller it is. That's going to look ridiculous in there, so I'm going to try to clean up the board. Alright, so I took some Q-tips to that part of the board, and it looks so much better now. I haven't even removed the cap yet. But wow, there's just goo everywhere. That was really disgusting. Here is, here's one of the Q-tips I used. That got really dirty. This side got a fair bit dirty as well. I don't know where my other Q-tip went. I think I dropped it somewhere, but Yeah. Disgusting. Ugh. When caps blow up, you get a mess to clean up. Luckily, that's really the hardest part. The hardest part of this so far was the strain relief. Now what I have to do is desolder the capacitors and put the new ones on. So that should be pretty painless, actually. Just desolder everything. Oh. There's my other... Yeah. Anyway, I'm going to throw that out. And what I'm going to do is desolder that cap. I need to figure out what the polarity is on this, if it even matters. I've never replaced one of these X caps before, so I gotta figure all that out. Okay, I've desoldered that X cap over here. Let's see if I can get this off on camera, because it's just... it's gross. Move, brown wire. You're in my way. Oh, there we go. Oh, man, look at that. That cap exploded. That's gross. So, as you can see, it looks like it was definitely a metal capacitor on the inside, I think. It's kind of hard to tell, but... you know, it's... there we go. Yeah, it's a little discombobulated there. What I am hoping is that the new capacitor works in there just fine. We'll see. I mean, I don't know. If that one goes pop, I'll just try. I'll do more research and try another one. What I'm going to do is have the writing, since there doesn't seem to be any polarization markings, I'm just going to have the writing on the cap go the same way as the writing on this cap did. Which, you know, you could read the top of it the right way if it was in this orientation. So, as you can see, there's still some goop down there. I'm going to get a Q-tip and clean that off. Alright, so I've replaced half the capacitors on the input side. You can see that new x-capacitor is really small. I hope this cap works. I actually talked to Cube Computer channel about this particular capacitor just because he knows a little bit more about this than I do, and he told me, as far as the polarization goes, that there is no polarization here. It literally is between, what did he say? He said they're not, as far as he knows, they're not polarized. They're connected to between hot and neutral sides of an AC supply. So thank you very much, Cube Computer channel. Thank you very much, Nick. You're very helpful in that regard. Just because I didn't want to screw this up, since this is for somebody else. I've just never replaced an X cap before, so I just need to know that simple information. And sometimes the internet doesn't answer it that well, so it's good. It's good to have buddies. So anyway, as you can see, these are the new caps. They're quite a bit shorter than the old ones, as you can see. So over the years, they've changed a little bit. The new ones have venting, little venting weak spots on the top. So if these ever go bad, they'll just go out of the top instead of from the bottom and all around. So yeah, but luckily the polarization on these is very clear. These boards are actually marked very well. So thank Apple for that, or not Apple actually, Aztec. They made the power supply. Aztec did a good job with this power supply. So replacing these caps has been smooth sailing so far. Really not that hard. Cap jobs are easy. So this is actually kind of fun for me. So what I'm going to do is get the rest of these caps out of here and replaced, and I'll show you the results. Alright, we're back. I've soldered everything. This is the solder I use, just in case you're curious. Just regular 6040 rosin core solder. You can tell it's old by that old Radio Shack logo. Plus this really, really crappy soldering iron that I got from Radio Shack as well. But you can swap it between 30 watts and 15, so it's okay. It's really, really crappy equipment, but it gets the job done. I'm done with it now, so I should unplug that. So we've resoldered everything. my soldering isn't... I didn't resolder everything, but I soldered some new stuff in. You can tell that I had to fight with some of the joints with my desoldering iron to get it out. There's some scratches on the board. Luckily, it didn't go through, so it's fine. But yeah, all the soldering looks good. My soldering isn't the best, but it isn't the worst either, so... yeah, here's a view of the board after it's had everything replaced. There you go. New capacitors over here. New x-capacitor there. New cap here. All new caps on the output as well. Here, 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 here. And there you go. Everything. I left everything else alone. The diodes, the resistors, all that stuff has been left alone. And the voltage regulator there, it's been left alone. So now I just got to put this back in its put it back in its case and test it, and hope that all these caps, you know, fit the bill and work. I think these caps will be fine. I know all the electrolytics will be fine. My real question is, will that X cap work? So I'm going to turn this on and hope the X cap doesn't go pop. I've never replaced an X capacitor before, so we're going to find out. I'll be wearing goggles for sure. So, yeah, I'm gonna wrestle with this thing, get it back into its case, and then we'll check it out, see if it runs. I'm gonna get the multimeter out and we'll test it. Okay, it's been a couple more days, and I've got the power supply back in, all repaired and ready to go. Had to look back at my video footage to see which one of these I had to plug into the switch. In fact, see the brown wire down there doesn't seem to want to stay on. Let me get that back on real quick. Yeah, I got that brown terminal back on there a little bit more tight. But anyhow, I got the whole thing replaced. I got the ground wire back on. Have the strain relief reinstalled. I'm surprised this rubber hasn't gone bad in all these years. Connector still looks good. So I don't know how I'm going to test this, but I'm just going to make sure there's voltage. I'm just going to make sure there's voltage coming out of each of the terminals, and you know, all should be well. And first of all, we're going to have a smoke. I think most important of all, we're going to have a smoke test to make sure I didn't screw anything up. So we will do that. There, I got that stupid brown terminal down there straightened. The little film capacitor right there was getting in its way, so yeah. Anyhow, I think we're ready for a test. What I'm going to do is just throw the top on. Throw the top on without screwing it in, and we'll just see what happens. Coolio. So now we just got to get a power. Now we just got to get a. Yeah, what I can do is I'll throw the bottom cover on and I'll just lay it like that. And we'll look at the pinout here. These are your two common grounds, it looks like. So what we want to do is test five. These are your common grounds, and these are your plus 5 and minus 5, plus 12, minus 12. So I'm guessing what you do to test these is just do the positive and the neutral, and with a meter, and see what you get. Let's find out. Okay, we have our test set up here. I have it plugged into the pinout for the 5 volts, which is pin 3 and 6. If you look at the diagram there, you get pin 3 is 5 volts, pin 6 is minus 5. So I've plugged the negative into the negative and the positive into the positive, obviously. I have it hooked up to my multimeter here. And just to check continuity, we'll turn that on. And we have continuity. Alright, so I tested it a little bit earlier. Drain the voltage here. So here's how I have it set up. I have the meter probe stuffed into the connector. I have a power strip here, and I have the power supply switched on the back, so I'm controlling it from the power strip. Okay, so let's turn this on, and you can see we get a reading on the meter, which is good. And then you turn it off and the reading goes down. So it looks like our power supply recapping was a success. The X-cap didn't blow up when I first turned it on, which is what I was most worried about. The other caps are exactly what they're supposed to be, so looks like we have no problems. Let's test 12 volts now. First I'm going to drain the caps using the continuity. That seems to drain them, which is nice. Alright, so pull these out of here. I'm going to turn continuity on, actually. So for 12 volts, we want pins 4 and 5. So put the positive in there. Put the negative in there. And we have continuity. So let's turn that off. Go back to the 50 scale there, or the 25 scale, I think is what I was on. Turn the power supply back on again. And we have voltage. Nice. So it looks like this is a success. There was no popping. I hear the power supply whine a little bit when I turn it on and off, which is a good sign. That means it's responding. I don't know if you can hear that with the camera. That'll at the end. It's like a little mouse squeak. Let's drain the capacitors with some continuity there. Yeah, it's got nothing in it now. All right, there you go. I'm gonna drain the 5-volt rail as well, just because I'm gonna be shipping this thing. Drain that. There you go. Get nothing out of it now. That's what you want. Turn the power supply off. Looks like this repair was a success, folks. This is my first repair of a vintage piece of equipment that wasn't an audio amplifier. A computer power supply. It looks like these power supplies are pretty easy to repair. There's not much to them. There are literally two rails and a common ground, and that's it. It's much less complicated than, let's say, this Delta power supply here, where there's, there's a bunch of rails. There's a 5-volt rail, 12-volt rail, 3.3 volt, and then there's standby and all that kind of stuff. These newer power supplies are a lot more complicated than the older ones, because older computers just didn't need that much power to run. There weren't as many fans. There really weren't hard drives at that point. It was just floppy drives and a bunch of solid-state hardware. So old computers really don't need a whole lot to run. Very simple power supplies here. So that's pretty cool. So I'm going to ship this back to Roadgeek, have him put it in his Apple II, and have him enjoy the joys of vintage computing. So I guess one thing that hasn't changed in a long time is Apple puts 1 billion screws in their things. Although this power supply was made by Aztec, not Apple, but still, it's in an Apple product, and it has 1 billion screws to keep the bottom cover on for the power supply. So that's normal, though. I think that's for shielding. So let's unplug this, and I'm going to call this a success. Of course, we really won't know for sure until Roadgeek plugs it back into his Apple II. But judging by the tests and the results I'm getting out of the meter, I'd say this was a resounding success. We'll find out. I'm sure a Roadgeek video will come in the future, and we'll find out just how successful that was. I'm 99% confident that repair was a success, though. So there you go. I'm going to take this screwdriver and put all the screws back in, and get this thing shipped off to Roadgeek probably tomorrow, or maybe even I have time today. I should be able to do that today. Sweet. Okay, I got all the screws back in. One thing I did, actually, because some of these screws don't fit in their threads that well anymore, is I used some of this Permatex blue on it, which is basically just blue Loctite. So I did that to hold some of the screws that don't stay in their threads back in quite well enough. I used specifically the blue stuff because you can get it back in there again if you want, rather than the red Loctite, which needs to be hot to get rid of. So blue Loctite, just like the manufacturers use. There you go. Power supply should be all ready to go, so now I just need to go find the box this came in, pack it up, and send it over to roadgeek. Seems like everything is ship-shape to me. I should probably take the probes out of the connector. That might be a good idea. Yeah, this was a fun project. Had a little help from Cube Computer Channel, basically just asking him about a single capacitor, the x-cap in general. And he was, I mean, he didn't say anything extraordinary, but he definitely was helpful. So thank you, Nick. You're the man. Anyhow, there you go. That is the end of this project. Look at that beautiful Apple logo there. Just one last look at this thing. There you go. Aztec power supply made for the Apple IIe. This thing will be sent off to roadgeek, and he will enjoy vintage computing yet again. We're kind of introducing him to the world of 80s computers with the Apple II, and personally I think that's a really good introduction. So there you go. Repairs are complete. Tools are being put away. Life is good. So I hope you all enjoyed watching me document the repair I did on this. I mean, I didn't go into super detail because there really wasn't much to this repair, but it was a fun one. I enjoyed it. So there you have it, folks. Hope you enjoyed this video, and have a good one, everybody. Ciao.